For this next lab, we're using pentyl alcohol and HCl. We have our 3 milliliters of pentyl alcohol right in here, and we're going to add that to our separatory funnel. And we want to make sure that the separatory funnel is closed so that it doesn't just drain out. And we've got it set up in a ring stand. We're going to go ahead and add that in. And then I've got 7.5 milliliters of 12 molar hydrochloric acid. This is nasty stuff, so make sure that you're being careful with it. Now, I'm not wearing gloves, but that's just because I know that if I get any on me, I can just wash it off really quickly. And I'll be fine. So, now that I've got these both in the sep funnel, I need to make sure I've got a stopper that fits properly. I put it on, and then I'm going to shake this because my reaction is actually going to take place in here, but I have two things that are not going to dissolve in each other, right? I've got an aqueous thing and I've got the alcohol. So now to shake this, you grab the top and you hold it like this and you turn it upside down. That's why we want to make sure that this stopper is the right size, and we're going to just shake it vigorously, but that can sometimes build up pressure inside, so we want to vent it. I can shake it, you turn it over, and you vent it. And when you vent it, make sure you're not pointing this at somebody. Right? We're going to do that several times. And we're going to keep track of how long we have this in there, because we've got our reaction is going to take about 10 minutes. And we need to shake it every so often. Alright, so it's been 10 minutes of mixing and venting and making sure that when we tip it upside down, we've got it just nice and easy. We vent it, then after we vented it, we close it back, making, before we turn it upside down or before we start shaking again, we'll put it back. Alright, next we're going to neutralize all the extra HCl. So we've got a couple milliliters of the 5% sodium bicarbonate solution here. We're just going to add that in, and we should make a gas, right? So we don't want to necessarily add the stopper right away, because we're going to neutralize some of that extra acid in there. So venting is going to be really important here. So we're going to again shake that. Add a little bit there, again, just because we're making some gas from the neutralization reaction. So we're going to do this a few times to get all of the extra acid out. Now, each time we're going to drain off the aqueous layer. So where's the aqueous layer? Well, usually it's on the bottom, but in some cases it could be on the top if we had a very dense organic fluid. So that's one of the other reasons to note down the densities in your lab notebook. In this case, it should be on the bottom though, I believe. And it can be hard to see the layers, right? But there it is, right there. And so a lot of this is aqueous, and that should make sense because we added quite a bit of HCl into this, right? So the aqueous layer should be pretty big. Now, save yourself some heartache and make sure that we don't throw away any of the layers that were in the sep funnel until we are sure that we have our product and we have our right layer, right? At that point, then you can clean up and get rid of it. So just heads up. So you're just going to slowly drain out this aqueous layer. And when it gets down towards the bottom, the layers will be easier to tell apart. Now, it's not important at this stage to get all the water out, so we're just going to leave some of it in, because we're just going to add a little bit more of the bicarbonate solution anyway. And we're going to repeat this at least 2 more times. Alright, so far we've done 3 washings with the sodium bicarbonate solution, and we've drained off the bottom layer, which should be the aqueous layer, into this beaker. This is a waste beaker, but we're not throwing this out yet because we don't have our product completely, and I always like to just set this aside just in case. Now, we tried to get all, or as much as we could, of the aqueous layer out of the separatory funnel before we continue on. And there's a little bit of water down there, so I'm going to wipe that off. So next we're going to drain this off into an Erlenmeyer, and then we're going to dry it with some sodium sulfate drying reagent. So we've got our organic layer, and then we'll just come over and we'll put some drying agent in it. So let's add our drying agent to this, and so we've got our sodium sulfate, and we just want to add some to it, and then we'll check and see if we've added enough. Now the way to check and see is we'll just swirl this around. We can cap it if we want to while we're doing that, and we just want to watch. Does all of it clump up? And if all of it clumps up, then we'll just add a little bit more drying agent. And we may need to add quite a bit, especially if we accidentally got extra water in from our separatory funnel. So try to get as much of the water out before this step, so we don't have to use lots and lots of drying agent. I'm going to put in a little bit more, just because it looks like it's kind of all clumped up, and that won't hurt us to add a little more. So let's go ahead and stick some more in. And then make sure we cap the container really tightly so that we don't spoil the rest of our anhydrous salt. And this will probably be enough, even if it's a little clumpy. We'll let it sit for a few minutes and make sure it pulls out all the water. All right, so now we're going to add our dry product mixture into a short neck microscale flask. I'm just going to use a pipette for that so that it's easy to transfer. I want to get all of it in there. Okay. All right. Then next, I'm going to assemble the rest of the distillation head. So here's the microscale distillation head, and I've already put the thermometer adapter and the thermometer in. Now when I was pushing the thermometer in, I grabbed it very close to this. If you try to push it from higher up, you might break the thermometer, and glass might go into your hand or cut you or something, so don't do that. So these just snap together, just like that, and then we'll have our receiving flask right there, and we'll put this in a beaker, and we'll put a little ice bath around that beaker, and we'll start the distillation. So we'll get that going. All right, so far this is our setup. We've got our heating well and it's warming up, and then our product and probably a little bit of the starting material, unreacted starting material is in here. And we have our distillation apparatus over to our receiving flask, which has a little bit of ice in it to help cool it down. Now this is an air condenser right here, so it just operates on the fact that the glass will be cooler than what's flowing in, and that's how it will condense our product. So at this point we just need to wait for the distillation to happen. We should also note that we've added some boiling chips into the flask along with our compounds that we wish to distill. This will just help us make sure that the boiling is smooth and it doesn't bump or pop. It just gives it a place for the boiling to start. So here's the bottle of those. These particular ones are made of Teflon, and they just sit down there. So just put like maybe two or three in there, just to ensure that the boiling is smooth. And you can reuse these if you want to or not, either way. All right, so now we have started the boiling, and we don't want it to boil too fast because we want the distillation to be able to actually separate the compounds. So now is the time for a little bit of patience with this. So we're just going to watch, and when it starts coming up here, there will be a little bit of a solvent. You'll be able to see it come up the flask, and it'll start collecting on the thermometer, and that's when the temperature of the thermometer will start to climb. And we're going to want to pay attention over here to our receiving flask, and we want it to be a little bit slow process, like maybe a drop a second or drop every other second. If it's too fast, we just won't get a good separation. All right, so we've got the fluid is now coming right up about where the thermometer bulb is, and you'll notice that the temperature has been climbing. Now, just a little side note here, we've got our thermal well set on about 4 so that we can get the solution hot enough to actually distill. So any second now we're going to get a little drip over to here, and you just saw one drop off of the thermometer. Once the thermometer gets warm, then the material will distill over into here and then condense in our receiving flask. All right, so we've distilled our liquid here, our product. Now, we've stopped it before this flask went dry, and we need to make sure that we do that because you never want to distill a flask completely to dryness. So even if we lose a little bit of our product over here, that's what we have to do. And I've just raised it up out of the sand bath to keep it from doing that. What can happen is your flasks can crack and break if they get too hot too quickly, and letting a flask go to dryness will do that. So we've got our product over here, and there's quite a bit of it, and we're going to go get an IR of this and measure the mass of this product. And if I was thinking ahead, I would have recorded the mass of this particular flask. So I would suggest that you record the mass of your flask before you start this process, but we'll just transfer it to a different flask and lay it there. All right, and your professor or your TA will help you with the infrared machine or instrument, and we'll be done with this lab.